Buildings in severe cold and cold regions must have sufficient thermal insulation to ensure the comfort of the indoor thermal environment in winter, while controlling building heating energy. Buildings in areas with hot summers and cold winters also need to consider thermal insulation in winter. Therefore, building thermal insulation and energy-saving design are important components of architectural design. In the design of building thermal insulation and energy saving, in order to make full use of favorable factors and overcome unfavorable factors, the following design strategies should be paid attention to. 1. From the perspective of energy saving and sanitation, it is necessary to make full use of solar energy. 2. To prevent the adverse effects of cold air. The adverse effects mainly include cold air penetration and increase the heat dissipation of the outer surface, which can be achieved by changing the air tightness of the doors and windows and avoiding the large area of the outer surface, facing the prevailing wind direction in winter. 3. Choose a reasonable building shape and platform. Avoid excessive shape coefficient and excessive tortuous and convex concave resulting in excessive cold breach. 4. Make the room have good thermal properties, so that the building has the overall thermal insulation and heat storage capacity. The room that is used continuously should have good thermal stability to prevent the room temperature from fluctuating too much when the outdoor temperature drops or the heating falls. Materials with high density and high heat storage coefficient. Rooms used intermittently require that the room temperature can quickly rise to the required standard after heating is started, and materials with low density and low heat storage coefficient should be selected for the inner material of the envelope structure. At the same time, it should be ensured that the heat transfer coefficient of the outer building envelope meets the requirements according to the requirements of building energy conservation. When some parts do not meet the requirements, the area or heat transfer coefficient of other parts can be adjusted to make the overall heat consumption index of the building meet the requirements. 5. The building insulation system is scientific and the node structure design is reasonable. The building thermal insulation system is composed of thermal insulation material layer and base layer, plaster layer, and finishing layer. Due to the different applicable conditions, construction technology, and economy of various thermal insulation systems, the scientific method should be determined according to the function, scale, and local climatic conditions of the building insulation system. The abnormal heat transfer paths in the outer envelope structure include the corner of the outwall, the intersection of the inner and outer walls, the intersection of the floor or roof and the outwall, parapets, overhanging balconies, awning, and other components, and reasonable node structure should be selected for these paths. 6. The building should be equipped with a comfortable and efficient heating system. Buildings that are used continuously can use low-temperature hot water for continuous heating, and buildings that are used intermittently can use hot air heating for extra duty heating, so as to ensure that the indoor thermal environment meets the thermal comfort standard and improve energy utilization effectiveness. Severe cold regions have the following requirements for building energy-saving structure design. 1. Select the node structure from the National Standard Design Altars according to the applicable scope. 2. External insulation is preferred. 3. Minimize concrete overhanging components and wall-touched components. 4. Cut-off or heat preservation measures are taken at the thermal bridge, and the gap is closed with elastic heat preservation material. 5. It is not advisable to use overhead water storage and planting roofs. 6. Gutters should be insulated, and the insulation layer at the junction with the roof should extend into the wall and ensure that the protruding length exceeds 1/2. 7. The overhead or overhanging floor whose bottom surface is in contact with outdoor air should adopt external insulation. 8. The bottom ground should be insulated to more than half of the depth of the local frozen soil layer on the outside or inside of the foundation. Think about it. The above design strategy all require the building to have sufficient air tightness. How to solve the problem of ventilation and lighting. How to design the building to reduce the shape coefficient. The energy saving index of residential buildings is completed by the enclosure structure and heating system. Based on the energy consumption of 4-unit and 6-story residential buildings in General Design Method of Local Residential Buildings from 1980 to 1981, the energy saving proportion of enclosure structure is 50%. According to the energy saving design standard of civil buildings, the limit value of heat transfer coefficient of external enclosure structure in various regions is given, and the average heat transfer coefficient of external wall considers the influence of surrounding thermal breeze. The thermal performance of partitions and doors is not restricted because staircase heating is required when the average outdoor temperature is below -6.1 degrees Celsius. On the premise of controlling the maximum heat transfer coefficient of each part of the enclosure structure, the energy saving design of residential buildings is required to control the heating consumption index and the cold consumption index of the building equivalent to the unit building area. This method is called building energy consumption control method. The thermal design requirements for non-transparent enclosure structure of public buildings are: 1. The shape coefficient of buildings in severe cold region and cold region should be less than or equal to 0.4. 2. The heat transfer coefficient of enclosure structure should not exceed the limit value in certain climatic zones. Because public buildings focus on building facade and function, sometimes it is difficult to fully meet the heat transfer coefficient limit. The energy saving design of public buildings adopts the trade-off judgment method. This method is based on the control of the total energy consumption of buildings, focusing on whether the overall thermal performance meets the requirements of energy saving standards. It is a parametric design method. The specific approach is to consider a virtual building as a reference building, calculate the annual heating and air conditioning energy consumption of the reference building and the actual design of the building, and judge by comparing the two energy consumption. When the energy consumption of the actual design building is greater than that of the reference building, some design parameters are adjusted, such as reducing the window area and improving the thermal insulation performance of the window. The energy consumption of the designed building is recalculated until the energy consumption of the designed building is no longer greater than that of the reference building. Reference building in all aspects of building envelope should be in line with the provision of the energy saving design. Dynamic calculation of building heating and air conditioning energy consumption is a very complex process. It is necessary to use building energy efficiency design software, such as DeskEdge of Tsinghua University. It is necessary to unify the building conditions to make the calculation results comparable. How to use the above building insulation and energy conservation design strategy. You can try to analyze the physical buildings according to these requirements, including traditional excellent buildings and modern buildings. You can also try in the architectural design work or use energy saving software for energy saving analysis of architectural works.